Hi everybody, Mr. Rubo here, and today we are looking at 211, which is logarithmic functions, which we're just going to look at the key characteristics. All right, so because log functions and exponentials are inverses, the characteristics of these graphs will have inverse relationships. So if you know one, you kind of know the other. So here's our key characteristics. So we have our log general form, a log base b of x, where b is greater than 0, and a and b are constants, with a not being equal to 0 and b not equal to 1. So what ends up happening is if you want to see some examples, here's two examples here. This is when a is greater than 1. Here's where a is less than 1. And b again always bigger than 1. Sorry, not always bigger than 1, but it's where it is bigger than 1 in these two cases. You'll notice in general they do follow this pattern, that it goes from 0 to infinity for the domain, and the range is negative infinity to positive infinity. This can change, right? If you have some reflections and things like that, but just like an exponential, growth or decay, your domain was always the same, of negative infinity to infinity. Well, that's now our range. And then the range of the exponential was the other way, right? It was always 0 to infinity, or 0 to negative infinity to 0. It'll be kind of similar for logs. All right. Logs are always increasing or always decreasing, just like exponentials. Always, oops, I forgot the S there, always decreasing. Okay. They will never switch from one to the other, so they have no relative extrema. Unless, of course, you restrict your domain. If you restrict it, then obviously you will have it. All right, and then log functions are also always concave up, or always concave down. They will never switch concavity, so they have no points of inflection. Okay. So just like exponentials, right? All right. End behavior, though, for logs in general, as the input value increases without bound, the output values will also either increase or decrease without bound. Now, because their logs have a restricted domain, they have the vertically asymptotic behavior to x equals 0. As a result, the left end will occur as x approaches 0 from the right. So it's a weird situation because logs don't have the all real numbers for their domain. They have a restricted domain. So that means your end behavior doesn't go to negative infinity. It goes to 0 from the right, unless it was flipped, and then it'd be 0 from the left. But 0 from the left, 0 from the right. So, and your answer is either going to be positive or negative infinity. And then for the right side, as x goes to positive infinity, it would be the same idea. It would be either positive or negative infinity. These two will be opposites of each other, though. So if you have positive infinity here, the other one will be negative infinity, and vice versa. Okay. And yeah, that's kind of a fun thing with logs, is they have the restricted domain, which we really haven't done a lot with functions that have that, unless we restricted it ourselves. But logs in general have a restricted domain. So, all right, well, thanks for watching and have a good day.